Welcome to another physics class. As I promised in our last lesson that we are going to continue with our example under equation of linear motion. By then we treated about 6 examples. So today let's continue and have more examples on it and how to use the equation of linear motion to solve problem. The equation on the board says that a particle moving in a straight line with uniform deceleration has a velocity of 40 meters per second at point P, 20 meters per second at point Q, and come to rest at point R. The distance between QR is 50 meters. Then calculate the distance PQ, time taken to cover PQ, time taken to cover PR. Now, to solve the question now, as I always say, please, if you are new to this channel, please try to like, share, and subscribe. When I upload a new video like this, you will be able to get the notification in time. Now, according to the question, the particle, let's show the motion now. Decelerate. Let's say this is point P, according to the question. This is another point Q, according to the question, and this is another point R. The question says the velocity at point P is 40 meters per second, and the velocity at point Q is 20 meters per second. And the body comes to rest at point R. It means the velocity here, since come to rest, will be 0 meters per second. The distance between QR, distance between this QR is 50 meters. Now, the first question says we should calculate the distance between PQ. Mind you, the question says uniform deceleration. At least the deceleration from here to here and from here to here will be the same. So, since we know the distance between QR now, the first thing we need to calculate is to calculate the deceleration between QR. Deceleration between QR. Now, for this, we have the initial velocity between PR, U, is equal to 20 meters per second. V is equal to 0 meters per second. Now, why is it 0 here? Because the particle come to rest. Now, the distance S is known between QR, 50 meters per second. 50 meters, that distance. What do we need under this one? We need A, which is deceleration. Now look at it now. If you write our possible formula, like equation 1 say V is equal to U plus AT, equation 2 say S is equal to UT plus half AT square, equation 3 say V square is equal to U square plus 2AS. What you need here is A. Time is not given, so both equation 1 and 2 is not suitable to solve this equation. So we now use equation 3 by saying V square is equal to U square plus 2AS. Now we need A. Make A the subject of the formula. That will be V square minus U square is equal to 2AS. So A now will be equal to V square minus U square over 2S. So having known our V and U, so we can now say that our V is 0 square minus 20 square over 2 multiplied by 50. This one will now give us 0 minus 400 over 100. That is 2 multiplied by 50 will give us 100. So from there now, we are going to have A will be equal to minus 400 over 100. So the answer will be minus 4 meter per second square. That is the deceleration between Q and R. And mind you, the question say uniformly decelerated. If it is uniformly decelerated, then it will have the same deceleration throughout. If that is the case now, we will be able to calculate the distance PQ now. Now to calculate distance PQ now, distance PQ. What are the parameters given? Here we know our U is equal to 40 meter per second. 40 meter per second. Between P and Q, V is equal to 20 meter per second. A already is known, deceleration is already known. That is minus 4 meter per second square. Then what do we need? X, that is the distance. S is not known. So without wasting our time, if we look at this parameter also now, compare with these three equations, we quickly say that it is only equation 3 that can solve it out. Why? Because time is not given. Later, the question asks us to calculate time. So we can now use equation 3 by saying V square is equal to U square plus 2AS. Make S the subject of the formula here. We are going to have V square minus U square is equal to 2AS. Now, S now will be equal to V square minus U square over 2A. This one will now give what is our V square minus 40 square, that is V minus U over, don't forget the A we got the other time is minus. That's 2 multiplied by minus 4. So from there now, this one will now give us 20 square will give us 400 minus that 1,600. 1,600 over minus 8. Now, it will now give us minus 1,200 over minus 8. Minus will cancel minus, and the distance between P and Q will be equal to 150 meter. Now, the next question is time taken to cover PQ. Now, from what we have seen on the board now, time taken T to cover PQ is not known. V is already known, that is 20. U is known, that is 40 meter per second. Then what else do you need? A is known, minus 4 meter per second square. Now, according to our formula, V is equal to U plus AT, S is equal to UT plus half AT square, and V square is equal to U square plus 2AS. We can now say that we need time here now, and the best or suitable equation for this one is equation 1. So by saying V now is equal to U plus AT, we need time. So that will be V minus U is equal to AT. T now is equal to V minus U over A. So from there now, we can now say that what is our V? 20. Our U? 40. Our A? Minus 4. So from there, this one will now give us minus 20 over minus 4. The answer will give us 5 seconds. That is time taken to cover PQ. Now the last question under here is time taken to cover PR. PR. Already we've know time taken to cover PQ. Now the first thing to do is to calculate time to cover QR. So to calculate time to cover QR, here now V is 0 meter per second because it come to rest. V is equal to 0 meter per second. Then U will be equal to 20 meter per second. Then A is known, minus 4 meter per second square. Then what do we need? T. That is, what kind of T now? That is, before we want to calculate time to cover QR, that is, time to cover QR. So from there now, using the same formula, V is equal to U minus AT. So without wasting our time, as we did here, our T now will equal to V minus U over A. Our V there is 0, U is 20, and our A is minus 4. That one will be minus 20 over minus 4. This one also will give us 5 seconds. Now, therefore, time taken now to cover PR now, time taken to cover PR will be equal to time taken to cover PQ plus time taken to cover QR. That is, time taken to cover PQ plus time taken to cover QR. And time taken to cover PQ is 5 seconds. That is 5 plus 5. So the answer will give us 10 seconds. Now, let's take this one as example 8. The question read on, two body P and Q start from rest, covering the same distance with different uniform acceleration of 2 meters per second square and 4 meters per second square respectively. If it take body Q 10 seconds to cover the distance, how long does it take body P to cover the same distance? So let's solve this one. So we have two body there. For body P now, for P, according to the question, U is equal to 0. Time taken to cover the distance is not known. T is not known. Then A is known, 2 meters per second square. Then we have to, since they cover the same distance, so SP will be equal to unknown. Let's assume with no T. So we put the T inside the equation. So from there now, let's write out our formula. V is equal to U plus AT. S is equal to UT plus half AT square. And the last one, V square is equal to U square plus 2AS. Let's see which one is suitable. We can now say that it is equation 2. Final velocity is not known, so equation 2 is suitable. You can now say distance covered by P now. Distance covered by P, call it SP, will be equal to UT plus half AT square. U is 0 according to the question, so this term will be 0. So SP will equal to 0 plus half multiplied by 2 multiplied by t square. Since we don't know t, so 2 will cancel 2. So SP will be equal to t square in meter. So for body Q, for Q now, let's write the parameter. They both start from rest, so U will be equal to 0. But according to the question, you take 10 seconds. T will be equal to 10 seconds. What time do you need? A is given. A is equal to 4 meters per second squared. Now, the distance for SP now. Distance for Q now. Distance covered by Q, call it SQ using the same formula, that's UT plus half AT square. Now, this time, since U is equal to 0, so you are going to have SQ will be equal to 0 plus half multiplied by 4 multiplied by 10 square. So from there now, we are going to have 2 will cancel, 4 divided by 2, that's 2. 2 multiplied by 100. That's 10 square. So this one will now give us 200 meter. Now, according to the question, they cover the same distance. It means both covered the same distance. So it means SP will be equal to SQ. And what we got for SP is t squared. That would be t squared is equal to what we get for this one for SQ is equal to 200. So that would be 200. So from there now, t now be equal to square root of 200. Now, this one will now give us 14.142 seconds. So it means, so the time taken for body P to cover the same distance as that of body Q will equal to 14.142 seconds. Now, let's take this one as example 9. A particle start from rest, moves with acceleration of 1.5 meters per second square. Calculate the 1. Velocity after 10 seconds. 2. Distance covered in 10 seconds. So, from this question now, let's write out the parameter. The particle start from rest. Definitely, U will be equal to 0. We have to calculate the velocity after 10 seconds. V unknown, then T is known, then A is given 1.5 meter per second squared. 1.5 A is equal to 1.5 meter per second squared. Now, without wasting our time, the correct equation to calculate V after 10 seconds will be equal to V is equal to U plus AT. U is 0, so we are going to have V is equal to 0 plus 1.5 multiplied by 10. And this one is 0 plus 15. So V after 10 seconds will be equal to 15 meter per second. The second question, distance covered in 10 seconds. Having all these parameters, we need distance for the question 2. S is unknown. All this one have been known. Now, according to our formula, equation 1 cannot solve it out. Let's write equation 2, S is equal to UT plus half AT squared. And equation 3, V squared is equal to U squared plus 2AS. So from what we've written on the board, it means the best equation to solve this one, once we need distance, should be equation 2. And once A is also known, you can use either of the 2 or 3. But let's stick to 1. By using equation 2, S is equal to UT plus half AT squared. What do we need here? 10 seconds is given. U is 0. So this term will be 0. That's S is equal to 0 plus half multiplied by 1.5 as acceleration multiplied by 10 squared. So this one will now give S is equal to 0 plus half multiplied by 1.5 multiplied by 100. So S will be equal to this divided by this 2, that's 50. That's 1.5 multiplied by 50. Therefore, finally, S will be equal to 75 meters. Take this one as another example. A train 90 meters long stopped in a station with its movers in line with a lamp post on the platform. Later, it starts off with an average acceleration of 0.45 meters per second square. Then what will be its speed when the mover pass the lamp post? That is, what will be its speed when the mover pass through the lamp post. Now from this one now, indirectly, distance is given. That is, the length of the train as 90 meters. It starts from rest, so U will be equal to 0 according to the question. Because the question is train 90 meters long, stop in a station with its mover. When it starts again, then the initial velocity will be equal to 0. Now, again, average acceleration is given. A is equal to 0.4 meter per second square. Then we now have to calculate its speed when the mover pass through the lamp post. So that is V, unknown. Now, according to our formula now, if you write our formula down, V is equal to U plus AT, that's equation 1. S is equal to UT plus 2 half AT squared, that's equation 2. Then equation 3, V squared is equal to U squared plus 2AS. Then under this equation, we need v. Time is not given, so equation 1 and 2 is not useful. So we are going to apply equation 3 by saying v squared is equal to u squared plus 2as. Our v is requested to be calculated. So v squared be equal to 0 plus 2 multiplied by 0.5 multiplied by 90. So from there now, our v squared is equal to 0 plus 90 multiplied by 2, that's 180. 180 multiplied by 0.5, that is 81. So from there, we can now say v squared is equal to 81. V now is equal to square root of 81. Therefore, the speed of that train when it passed through the lamp, when its mover passed through the lamp pole, will be equal to 9 meters per second. Let's look at this question. This is another question. A body moves with an initial velocity of 30 meters per second and accelerates uniformly until it attains a velocity of 80 meters per second. It maintains the velocity for some time and decelerates uniformly to rest. The total time taken is 40 seconds. If the time spent to accelerate is half that of traveling at constant velocity, calculate the 1. Acceleration, 2. Deceleration, 3. Distance during acceleration, 4. Distance during uniform velocity, 5. Distance during deceleration, and 6. Total distance travel. Now, to solve this one now, solution. Mind you, all these questions that we are using formula method to solve, we can also use what we did in our previous lesson, which is velocity time graph, to solve them. But in as much we said we want to use formula, that is why we stick to formula method. Maybe in our last example, we will use velocity time graph method to solve the last example. But let's use formula method to solve this one. Now, according to this question now, the initial velocity u is given 30 meters per second, accelerate uniformly and attain a velocity of 80 meters per second. It maintain the speed and use a total time taken. Time taken is 40. Let me write it. Total time taken is equal to 40 seconds. Now, the question is if the time spent to accelerate is half that of traveling at constant velocity. Now, let the time taken to accelerate be equal to t. It means time during constant velocity will be equal to 2t. And at the same time during deceleration, since it decelerates uniformly, deceleration will be equal to t. Now, to calculate the total time taken now, total time taken, according to the question, will be equal to t plus 2t plus t, then which is equal to 40. Now to calculate t now, then this one t, that's 3t, that's 4t. 2t plus t, 3t plus that's 4t is equal to 40. So t now is equal to 40 over 4. Then it will be equal to 10 seconds. That means that the time taken for acceleration, therefore, time taken for acceleration will be equal to 10 seconds. Time taken for uniform velocity will be equal to 2 multiplied by t is equal to 2 multiplied by 10. That's 20 seconds. And time for deceleration will be equal to 10 seconds also. That is 10 seconds, 20 seconds, 10 seconds. Now, to calculate acceleration now. Acceleration. Then it will now be equal to, using our formula directly, A is equal to V minus U over T. So according to this question now, our V is equal to 80 minus 30. According to what we have written on the board, time to accelerate now is 10. That is 50 over 10. Then that will be equal to 5 meter per second square. That is for acceleration. Deceleration, using the same formula, A is equal to V minus U over T. Our V here now, take note. The question says decelerate to rest. Decelerate to rest. So our V here will be equal to 0. Then our U, according to the question, will be equal to U will be equal to 80 meter per second. That is, the body accelerates to 80 before it comes to rest. So U now for deceleration will be equal to 80. So time taken to decelerate, have we calculated here, T is equal to 10 seconds. Put all this one, that one will be equal to 0 minus 80 over 10. That is minus 80 over 10. The answer will be equal to minus 8 meter per second square. And the next thing is distance during acceleration. Now, as usual, let's come here again. The velocity V is 80, U is 30. Then what else do we need? We know T. So we can use either of the S is equal to V plus U over 2 into bracket T, or V square is equal to U square plus 2AS. If you use these two formulas, we are going to get the same answer. Let's stick to one. So by using this one, You can use this one to try it again. We are going to see that we are going to arrive at the same answer. So S is equal to, what is our V? 80 plus, what is our U? 30 over 2. Time to accelerate, 10. So this one will now give us 110 over 2 into bracket 10. 2 here, 2 here. That's 110 multiplied by 5. So this one will now give us 550 meter. Or if you want us to try it together again, let's see, maybe we are going to arrive at the same answer. Our V is 80 and we need X. So make X the subject of the formula. V squared minus U squared is equal to 2AS. S now is equal to V squared minus U squared, then over 2A. This one, 80 squared minus 30 squared over 2. What is the value for A? Multiplied by 5. This one will now give us 6400 minus 900 over 10. Now, our S now equal to 5500 over 10. 0 will cancel 0, so we are going to have 550 meter. You can now say that we arrive at the same answer. Now, the next one is distance during uniform velocity. During uniform velocity, let's write out the parameter. According to the question, it maintains this velocity, that is 80 meters per second, for some time. Already we've known the time for uniform velocity. Our time is equal to 20 seconds. The speed at that particular point, which will be our U, will be according to, if you can still remember that during uniform velocity, our V will be equal to U. Don't forget that from our previous lesson. If that is the case, it will be equal to 80 meters per second. What else do we need? According to the theory, A at that particular point will be equal to 0. So which formula is suitable to solve this one now? Then we are going to have, without wasting our time, S is equal to UT plus half AT squared. This is the only formula that we can use. If you try equation 1, if you want to try this one, V squared is equal to U squared plus 2AS. We need distance. Time is known here, so this one is not usable. Try this one. This one also cannot solve it. So, because we don't know final velocity, so V cannot be equal to U, and this one cannot work it out if you want to use this one. So the only one that is applicable is S is equal to UT plus half AT squared. And we said when a body is moving with constant or uniform velocity, A is 0. So this term will be equal to 0, because 0 multiplied by T squared is 0 multiplied by M equal to 0. So it will be equal to, S is equal to, what is our U there? 80 multiplied by 20 plus 0. So this one will now give us, that's 1,600 meters. That is the distance during uniform velocity. The next one is distance during deceleration. Let's come back to the question again. The speed that it maintains, which is constant velocity, is 80 meters. It means the initial velocity during deceleration, U, will be equal to 80 meters per second. That is 80 meters per second. That is the speed, the velocity is maintained. When it maintains this one, it now comes to rest. It means the final velocity will be equal to 0. Now don't forget, we calculated the time taken the other time to decelerate as 10 seconds. So if this one is the case, then we can now use S is equal to V plus U over 2 into bracket T. Don't forget also, since we know the value of deceleration, we can also use V square is equal to U square plus 2AS. Make S the subject of formula, or so we are going to arrive at the same answer as we did the other time. So let's do it. Meter. Now U is 80, V is 0. Then multiply by 10 divided by 2. So that's 80 multiplied by 5, it will give us 400 meters. Let's try. Maybe we are going to arrive at the same thing. Make S the subject of the formula. That will be V square minus U square is equal to 2AS. S now is equal to V square minus U square over 2A. Mind you, our V is equal to 0. That will be 0 square minus, what is our U? 80 square over, don't forget, our A the other term is minus 8. That's 2 multiplied by minus 8. So this one will now give us 0 minus, this one will be, that's 6400 over 16. And from this one is 6400 divided by 16. That is minus 16. This one also will be minus. So minus will cancel minus. So the answer is 400 meters. So we arrive at the same thing. Now, the last question under it to calculate total distance travel. Since we've known distance travel during the acceleration, and we got a 550. Distance during uniform velocity, we got, that is 1600. Then the last but not the least, distance during deceleration, we got 400. By the time you sum everything together now, it will give us the total distance travel. So the total distance travel, adding together, we got to 2550 meters. That's all. Let's take this one as the last example. And as I said, we are going to use velocity time graph to solve it. So according to the question, you can start from rest at the checkpoint A and come to rest at the next checkpoint B, 6 kilometers away in 3 minutes. It has first the uniform acceleration for 40 seconds, then constant speed, and brought to rest with a uniform retardation after 20 seconds. After 20 seconds. Sketch the velocity time graph. Now, before we sketch the velocity time graph, let's note this one. This one, 6 kilometers. Convert it to meter. 6 kilometers to meter. That one will now give us 6 multiplied by 1,000. That's 6,000 meters. That's total distance. It means total distance S is equal to 6,000 meters. Then again, 3 minutes. 3 minutes. We cover the distance. The distance apart in 3 minutes. Convert 3-minute time. 3 minutes. That's convert it to second, to second, to second. That one got 3 multiplied by 60. That is 180 seconds. It means the total time taken equal to 180 seconds. Now, let's interpret and draw the velocity time graph. That is AVT. Velocity in meter per second. 0, 0, that's the origin, and this is time. According to the question, we start from rest. Let's say this is point A, accelerate uniformly, and during the acceleration, it at first the uniform accelerate for 40 seconds. So for 40 seconds, this is 40 seconds, from here to here, it then move a constant speed, but we don't know the time speeding, and come to rest and retard the next 20 seconds. So this is time in seconds. So time for retardation from here to here is 20 seconds. From here to here is 40 seconds. So they now mean that if we represent this place, the time taken during uniform velocity now, time taken during uniform speed, let's say is equal to s, that is this place is s. So, and the total time taken is 180 seconds. So it will now be equal to 180 will be equal to 40 from here to here plus s from here to here plus 20 from here to here. So this one will now give us 180, that will be 60 plus x. So 180 minus 60 will be equal to x. So it means now s now is equal to 120 seconds. That's the time taken during uniform velocity. Now, from there now, the question now asks calculate the maximum speed. From this graph now, that question B1 now, B1, maximum speed. So without wasting our time, since we are able to draw the velocity time graph, maximum speed, that one will now give us this. Let's clean up this one. That is the speed along this place that we don't know. But the question says, since we know the time at this particular time is 40 seconds, as I said, maximum speed is v. So to find maximum speed from this velocity time graph, this shape is a trapezium. We can now say the total distance traveled distance is equal to area of trapezium, area of trapezium, according to this is point A and this is point B, where it comes to rest. So that one will now be equal to half into, according to the formula, A plus B into bracket H. And from what we are written here now, our A will be from here to here, which is 120. Our B from here to here, which is 180. our h will be equivalent to the maximum speed we have to calculate. So let's insert this thing now. So our 6,000 now, which is total distance, be equal to half into 120 plus 180 into bracket v. We are looking for v as maximum speed. Cross multiply, or if you say 6,000 will be equal to 120 plus 180. So 120 plus 180, that will be half into multiplied by 300 v. Here, this one will now give us 6,000 is equal to 150 v. So without wasting our time, our v now is equal to 6,000 divided by 150. V now will be equal to 40 meter per second. That is the maximum speed. So since we have said v is maximum speed, so our maximum speed will be equal to v. Now, the next question says maximum retardation. Let's now look at the region for retardation, this place, from here to here. So using this formula, that question number B2, maximum retardation, that one from this, so from this region of retardation, that one will now give us A will be equal to the slope of this place, then the slope will be equal to delta V over what we have on the horizontal. As don't forget what we have done under the velocity time graph, and what we have here from here to here, luckily we calculated as 40. Time to decelerate is 20. So since that will be 20, and the answer to this one will be equal to 2 meter per second square. But the question says retardation, so you say minus 2 meter per second square. Now, to conclude this part, from here to here is 40, and from here to here is 120. 120 plus 40, that will be 160. So up to this will be 160. So 160 plus 20, that's 180. That's total time taken. So this one will be the velocity, complete velocity time graph. And mind you, within this question, we can still have to calculate acceleration. Let's add that question now to make it B3. Let's add that one, B3. Acceleration. Acceleration. So the question can say as such. And you look at the region of acceleration. So from here to here, that will be A will be equal to slope under this acceleration region. That will be delta what we have on the vertical axis during acceleration over what we have on the horizontal axis. And that one will now give us, we calculated V the other time from here to here, that's 40. Then from here to here, it used 40 seconds to accelerate. That's 40 over 40. So acceleration is equal to 1 meter per second square. Finally, and from this point, we are going to stop on anything on linear motion. We started from the beginning, and this one will be the convenient point to stop. We have many other calculations under this topic, but time will not permit us to continue like this to be solving all these problems. But if you still have questions, you are free to ask your question. Use the WhatsApp number on the channel to ask your question. And as I said in the beginning, If you are new to this channel, don't forget to like, share, and subscribe. So when I have new video like this, you will to get the notification.